Today we will discuss about, and that concept is known as a inheritance. What is inheritance? Inheritance is, you can say, one class. For example, I have a one class A and I have one class that is B. Now inheritance means this class is accessing the property of this class. That is known as an inheritance. For example, I have in class A, that is variable integer I comma j. Now this is the class that is B, which extends from A. So you can say this B has accessibility of this I and J, as well as this B can define their own. So in short, you can say the class, that is this class, class B, is known as a subclass. Some people says that this is a child class. Some people says that this is a derived class. In different technology, different terminology is there, but this all are same. If you say subclass, child class or derived class, all are same. In short, the class which has the property of its father is known as a child class or subclass, and the class which inherits all the properties to their child, that class is known as a superclass. Or you can say this is a parent class, or you can say this is a base class. So how we can achieve the inheritance? It is very simple. Using the keyword extends, we can access the property of father. So this extends A, it is used to make the inheritance. So this I and J will be accessible over here, as well as this class has something new. So you can say the subclass, that is the class B, is the specialized version of the class, or you can say it is the latest version. Which are the properties that class can access? This class, that is the subclass, can access only non-private members. For example, this class A has a private integer and that variable name is, for example, P. Then this P is not accessible by child. This child class B cannot access the variable P of the A. Why? Because this is declared as a private. So in short, you can say subclass can access. So what is inheritance? I want to write a simple definition. We can say a class can access properties and methods of another class except private member is known as a inheritance. So class can access the property. This class can access the I and J of another class and accept the private member, that is known as a inheritance. So you can say this is just a simple theory about the inheritance. Now I want to give you the practical demonstration of the inheritance. So let me start with the program in Java. Let me save this my file as Control S, and I'm saving this program as inheritance demo 1.java. Now I'm declaring here one class, that is A, which has the members, that is I and J. Now I'm declaring class B. This class B has the variable, that is integer K. Now I'm declaring here one function, that is void show ij. So this show ij will do what? It will print the value of I and J. For example, I'm just writing here system.out.println and I'm printing here I and J. Now I'm just initializing over here, that is the value of I and j. Let me write here, that is initializer block. I'm writing here I equal to 100 and j is equal to, for example, 200. Now this is, so ij is the value. Now this is the class B, which has the integer k, and I'm writing here that is k is equal to, for example, 300. Now I'm just making here sum. So this is my function, that is void sum. Inside this function sum, I'm just printing the value, and that is what I just did, I plus j plus k. Can I access the I and j over here? Yes, definitely. But if and only if this class B is extending from A. So this is a simple inheritance. You can say I'm accessing the property of class A, that is the parent class property I and j, inside the class B, and here I am accessing I plus j plus k. What is k? K is my current own instance member, and I and j is the instance variable of the superclass. And suppose if you are simply executing this class inheritance demo 1, let me write the main function over here. Let me create an instance. For example, a is equal to new a. So whenever you create an instance of a equal to new a, then this initializer block will simply execute all this. Let me call here a dot so ij. So your so ij function will be called. Let me compile here java c inheritance demo1 dot java inheritance demo 1. Then I will be able to access 100 and 200, but I want to create an instance of class B. So here, instead of creating an instance of A, if you create an instance of B, that is B equal to new B, and now if you call B dot sum, then you will get the sum of all these three numbers without creating an instance of class A. How it is possible? It is very simple. Whenever you create an instance of class B, it first create an instance of class A. So your base will be created first. Once your base is created, then your class B function will be called. So as a result, you will get 100, 200 plus 300, and your result will be 600. Let me compile this particular code and you can run this. You will get the 600. One more advantage is what? Using this instance B, I can access the function of class A. So I can call b dot show ij. So whenever you call b dot show ij, you will be able to access that particular function and you will be able to print the value of, that is I and j over here, that is 100 and 200. So it is very simple that you can say using the instance of class B, I can call the functions of class A. Why? Because B is a subclass which inherits from class A. So B can access all the property of class A except the private members. If you observe carefully over here, then what happened? I have not created an instance of A yet, but still my B can access the property of A. How it is possible? Because whenever you call the constructor of the child, it automatically call the constructor of super. So that is the complete hierarchy, you can say. For example, let me give you the one more demo so you people will get the better idea. So let me save this program as inheritance demo 2.java. Now I want to give you the demonstration that these are the three classes. Class A, class B extends from A, class C extends from B. It means that there are three different classes. In each class, I'm just writing here constructor, that system.out.println. This is, you can say, as constructor. And let me copy this particular code and you can paste over here. Here you can say this is B's constructor. So this is my B's constructor, And here I'm writing that is this is the constructor of class C. So this is C's constructor. Now I'm just calling here that is a C equal to new C. I'm calling only the constructor of the child class, that is a C. But whenever you create an instance of C, it first execute the constructor of the class B. Why? Because the C is extending from B. So it will call the constructor of B. But B will call the constructor of class A. Why? Because B is extending from A. So your A class constructor will be called first and you will get the message as constructor. Once it is done, your cursor will print the message B's constructor. Once it is done, your cursor will print a message that is C constructor. Inheritance demo 2. Here you can just compile this Java C inheritance demo 2.java. And whenever you run this, you will get the message that is A's constructor, B's constructor, and C's constructor. It means what? It means that first it calls the constructor of, whenever you call the constructor of C, it calls the constructor of superclass. So if you want to call the constructor of the superclass, you can write the super explicitly. If you are not writing the super, then by default compiler is writing the same line. So if you are writing like this or if you are not writing like this, both are same. If you are not writing like this, both are same. If you compile this, then you will get the same message, that is A's constructor, B's constructor, and C's constructor. Some people may say that, sir, you have written the super in class A. Then who is the superclass of class A? Then you can say each and every class has a superclass. By default, if any class has no superclass, then object class is the superclass of every class. So point to remember is object class is a superclass of every class. So every class has a one superclass and that is object class. So if you write here super, then object class constructor will be called, and in object class constructor there is nothing written, and that is the reason why I'm not getting any message over here, but it is executing all this in a sequence. So by default, a constructor having the first line, that is either super or this. If you are not writing super or this, then by default the first line will be super. So if you are not writing like this, then also you will get the same result over here. That is A's constructor, B's constructor, and C's constructor. So in short, you can say that the super is the default line that is written in the every constructor as a first statement. If you don't want to call the super, then you can write your own class constructor you can call, and that is you can call using the this, but you have to write explicitly that particular statement. If you are not writing any statement, then by default superclass constructor will be called. Let me connect the same with the previous example. Let me open inheritance demo 1.java. I have not created an instance of A, then also I can access the function of soIj as well as my value is initialized. Why it happens? Just because suppose if you says that I have a one constructor in class A in which I am just printing here message that A's constructor, and I'm just simply copying this and I'm writing here that is this is B's constructor. Right, now you can just save this and you can compile and run your inheritance demo 1.java. So whenever you write inheritance demo 1.java and whenever you run inheritance demo 1, you will get the message that the first A's constructor is called, then B's constructor is called. I have not called the instance of A, but still A's constructor is called just because there is an inbuilt line over here and that is super. So if you are not writing, then by default compiler is writing the same line and that is super. So first, before creating an instance of the child class, first instance of the super class is created, and then the instance of the child class is created over here. But what if I want to call my current class constructor? So if you want to call the current class constructor, then you can use this statement. So let me save this particular program as inheritance demo 3.java. So now we will understand the difference between the this and super. This refers to current instance while super refers to superclass instance. Let me first do the same thing on paper. Suppose if you want to access this k, then you can write here that is this dot k. So if you write this dot k, then you will access this dot k. But if you want to access I and j, then you can write super dot I and you can write super dot j. But don't need to write the super keyword if I and j is not declared over here. If you have the same copy, that is the variable shadowing, for example, what is variable shadowing? For example, I have one class A in which I have variable integer I and j. Now, I have one class that is B which extends from A, which has three variables: integer, for example, I, j and k. Now I want to access this ij as well as I want to access this ij also. So you can say this ij is known as a variable shadowing. It means the same variable that is declared in the parent class, the same variable is available in the child class. It is known as a variable shadowing. Now, suppose if you are printing this, for example, if I am printing here, that is I plus j plus k, then it will not access the value of ij from superclass. It will access the value from current class. So suppose if you want to access the value from superclass, then you can write super dot I plus super dot j plus k. No need to write here this. Why? Because this k is no ambiguity available over here. But in which situation this dot k is required? Let me give you the perfect example for the same. See here, that is I want to give you now one more demo. So I'm just saving this as inheritance demo 4.java. Let me make it here inheritance demo 4. Now I'm just declaring here one class that is A, and I'm declaring here one class that is B which extends from A. Now I have variable that is integer I comma j. I have one variable over here that is integer that is I comma k. Now if you look carefully over here, then I have two variables in A class and two variables in B class. But one variable is common in both the class, right? Then how we can access this? So it is very simple. For example, I have one constructor in B. I have one constructor in A. I equal to 100, J equal to 200. In B constructor I am writing that is I equal to, that is for example 300, and K is equal to 400. Now I have one function that is void display in which I want to access all this. So how we can access this? It is very simple. You can write system.out.println. Now suppose if you write here that is I, then it will simply access the I from the current class over here, right? Suppose if you write here that is plus k, then it will simply access the k from the current class. So if you call this function display, then you will get 300 and 400 only. See here, let me create an instance of b equal to new b, and I am calling the function b dot display. So whenever you call b dot display, And whenever you compile this, Java C inheritance demo 4.java, and you can run Java inheritance demo 4, you will be able to access 300 and 400 only. But if you want to access the superclass variable, then you can write here J also directly, plus J. And no need to write the keyword super. Why? Because there is no ambiguity available in the child class. So I can access all this, that is 300, 200 and 400. But what I want to access the variable that is available in the current class as well as in the super class, then you can write here, and that is super.I. So if you write super.I, then you will access this I, that is 100. And whenever you write I, you will get the 300 over here. And whenever you write J, it will simply access the superclass variable. Why? Because J is not common in the class B. So whenever you compile and run this, you will get all this variable, that is I, J, K. In which situation I have to use the super keyword? In the situation when the same variable or same function is available in the superclass as well as in the subclass, and whenever you want to access the superclass variable, at that time you can use the super keyword. But what if this I, J and K is available as an input in my display function? For example, let me save this program as inheritance demo 5.java. Now, this display function also has the variable integer I, integer j, and integer k. Now, I am passing here b.display and I am passing here the value, that is, for example, 50, 60 and 70. So if you write here 50, 60, 70, this is inheritance demo 5. Let me save this. And if you compile this particular program, now it's a wonderful thing. And if you compile this program, that is Java inheritance demo 5.java, and whenever you run this Java inheritance demo 5, it's a wonderful thing. Students, please see carefully. What happened? It displayed 50, 60, 70. Why? Because this is my formal parameter. Whenever you write I, it will simply refer to current block. If there is no variable declared over here, then it will look into instance. If it is not available over here, for example, slash star, star slash. If there is no variable available over here, if I am not passing any value over here, then it will simply access the instance variable. For example, if you run this, then you will get 300, 200 and 400. Suppose if this I is not declared over here, suppose slash star, star slash, then this I will refer to your superclass I. If you save this and if you compile over here and if you run this, you will get the same value over here, that is 300, 300. Why? Because the value of I is replaced over here, and that is I equal to 300 now, right? So my super.I is changed. Why? Because this I will not refer to current instance. Now this I will refer to superclass I, and that is the reason why I am getting here 300. But if it is not a comment over here, it means if it is a declared, and if you are passing here the value, and if you are passing the value, then what happened? Now this I, J and K will printed over here. So this I and K will not available over here. If you want to access this, then you can access using this keyword. For example, if you run this, you will get 50, 60 and 70 over here. Now, let me write here, let me copy this and let me print here. Suppose if I am writing that is this dot I, and if I am writing that this dot K, then this I and K will be printed, that is 300 and 400. So if you write IJK, then you will get 50, 60, 70. And if you write this dot I and this dot K, then current instance I and K will be accessed. Now, suppose if you want to access I and j of the superclass, then you can write here super dot I and you can write super dot j. So if you compile this and if you run this, then you will get 100 and 200 from superclass, 300 and 400 from current class instance variable, 50, 60, 70 is the formal input variable of function. So using this and super, we can use the instance variable of the current class and instance variable of the super class. As well as using this and super, we can access the function of the current class as well as the function of the super class. For example, let me save this particular program as inheritance demo 6.java. Now I have one function and that is void display, and here I am just simply printing the message that is system.out.println, and you can say as display function. This is the display function of A. Same function name, same type signature. Same function name, same type signature available in the superclass as well as in subclass, then you can say this is method overriding. Now, whenever you call the display function, you can say this is method overloading. Why? Because the same name with the different number of arguments. There are 3 arguments over here and there are no arguments over here. So this is method overloading and this is method overriding. Why? Because the same name, same function name with the same type signature available in the parent class as well as in the child class. It is known as a method overriding. Now, I want to call this display function. So how we can call this? Very simple. If you write here that I want to call display, right? So if you write here display inside B's dot display, then it will simply print that this is B's display. Why? Because this function is available in the child class. So it will simply call the function B's display. Let me save this as inheritance demo 6. Let me save this. Let me compile here inheritance demo 6.java. Let me run Java inheritance demo 6. You will get the message B's.display. Why? Because this is B's display. But suppose this function is not available over here. Suppose this displays function is not available over here. Then you will get the message and that is display. Why? Because this display function will first search for this type of definition in the current class. Is this definition is available over here? No. Then it will simply look into the superclass. Is this function is available in the superclass? Yes. Then it will call as display, and that is the reason why I am getting here as display. But I want to call both the function from here. Can I? Yes, using super you can do this. How? Suppose this display is available, then we all know we will get the message and that is B's display, not the A's display, right? But I want to call both A's display as well as B's display. So you can call super dot display. So if you write here super dot display, then it will call the function of the super class and that is A's display. And if you write simply display, then it will call the function of the current class. So using these and super, we can access the current class variable and superclass variable, as well as using these and super, we can access current class function and superclass function. Here also you can write this dot display, but it is not required at all. Why? Because there is no ambiguity of the same type of function is available in the same class. But you can write here this dot display. So you people can get the idea. Whenever you write this dot display, then it will call the function from the current class. And whenever you write super dot display, then it will call the function from the super class. Same function name with the same type signature, with the same number of argument is available in the parent as well as in child, it is known as a method overriding. And with a different number of argument, then it is a method overloading. Method overloading is known as a static polymorphism, and method overriding is known as a dynamic polymorphism. Some people says that it is runtime polymorphism, and some people says that this is static polymorphism. Some people says that this is early binding, and some people says that this is late binding. So based on your requirement, you can use the method overloading and method overriding. Using these and super, you can access variable, function, as well as you can use the constructor. So now I want to discuss what is the difference between these and super, and what is the use of these and super. So you can say this refers to current instance and super refer to parent class instance. Using these and super, I can access variable, method and constructor. If you write this dot variable, then you can access your current class instance variable. If you write this dot method, then you can access current class instance method. If you write here this, then you can access your current class constructor. Using super, you can access your super class variable. If you write here super dot variable name, then you can access instance variable of your parent class. If you write method, that is super dot, and if you write a method, then you can access method of parent class. And suppose if you write here super, then using super, you can call the constructor of the super class. In short, you can say using these and super, you can access variable, method and constructor. Using these, you can refer to current instance. Using super, you can refer to parent class instance. Let me give the example of the how to access the constructor of the current class and super class. So let me save this program as, that is inheritance demo 7.java. Now I want to show you how we can access the constructor of current class as well as super class. So I'm just declaring here the class that is A. I'm declaring here class that is B, which is definitely extending from A. Now I have one constructor in A class, and that is, you can say system.out.println is default constructor. So this is the default constructor of A class. Let me copy this and let me paste here. You can say this is the default constructor of B's class. Now I have one constructor B which has the parameter, that is integer number. So you can say this is parameterized constructor of B. So B have parameterized constructor. Now I'm just copying this particular thing and pasting over here. I have one more class C which extends from B. This is a C, and you can say this is a C's default constructor. You can call here C's parameterized constructor, and you can print the value, that is number, over here. You can print the number also over here. You can just copy this and you can paste into class A. You can say this is A's parameterized constructor. and this is number. If you look carefully, students, then I created the two constructor in all three class. One is the default constructor, another is the parameterized constructor. One is the default, another is the parameterized. One is the default, another is the parameterized. Now I'm just creating an instance of class C. So I'm just writing C equal to new C. If you create the instance of C, then it will simply call the current class default constructor. Why? Because I'm calling here default constructor C. Right? This is C's default constructor. So it will be called and it automatically write the super over here. So this super will call the constructor of the super class, that is B. So B will do what? It will call the superclass constructor of A. A will do what? A will call the superclass constructor of A, and as a result I will get the message A's default, B's default and C's default. So let me compile this code, Java inheritance demo 7.java, and let me run Java inheritance demo 7. See here, it printing me A's default, B's default and C's default. But what if I'm calling here parameterized? Suppose I'm passing here 150. Suppose if you are passing 150, that definitely your parameterized constructor will be called. So if your parameterized constructor is called, then what is the output? If you run this, then C parameterized, definitely it will call, but by default there is a one line over here and that is super. By default there is a one line and that is super, and that is the reason why it is calling B's default, and there is a super by default available in B, and that is the reason why A's default is coming. But I don't want to call superclass constructor default. So here you can pass value. For example, I am passing value that is 100, and here in parameterized B I am calling the super and I am passing the value, for example, 50. Right? So if you call superclass keyword over here and if you call the superclass constructor with the value that is parameterized, then that particular constructor will be called. Now instead of default, my all parameterized constructor will be called, and I will get the message that is 50, 100 and 150. But what if I want to call my current class constructor as well as the parameterized constructor? So if you want to do like this, then you can simply remove this, and if you remove this, then your default constructor will be called. If default will be called, then definitely your default will call all the default constructor, right? So here in default you can write this and you can pass some value. So this default constructor will call this default will call this, and current class constructor has the value that is 100. Now I am not writing here super. If I am not writing super, then by default superclass default will be called. If superclass default will be called, then instead of super I am calling this and I am passing 50. If I am not writing here super 50, then superclass default constructor will be called. Here superclass default will be called, and if default is called, then I'm calling here this. Let me make it here 50. Let me make it here that is 100, and let me make it here that is 150. You can save this. Now if you look into the flow, then what is the output? See carefully. See, whenever you call the instance of current class, that is the default constructor, then this default will be called. But this default will call this 150. So current class constructor will be called. So current class constructor, that is C parameterized constructor. So first parameterized constructor will be called and then default will be called. One thing. But this is calling the default of the superclass. So default of the superclass this. So it is calling what? That is current class parameterized. So current class parameterized is doing what? It is calling the default constructor of the superclass. So default constructor of superclass is what? That is, it is calling the parameterized constructor of the current class. So in short, in each and every flow, I will call parameterized constructor of A first and then default of A. Parameterized of B first and then default of B. Parameterized constructor of C first and then default of C. So let me compile this. And if you run this particular code, you will get the message that the A is parameterized as default. B is parameterized, B is default. C is parameterized, C is default. And I called only one line from here, and that is default constructor, and it is calling each and every constructor. In short, this is used to call the constructor of the current class, and super is used to call the constructor of the super class. If you are not writing any super or this, suppose if I am not writing here super, then by default this super will be written in each and every constructor. By default first line is a super if I am not writing here super, right? So if you save this and if you compile this, you will get the same result that you were getting earlier. So no need to write this super if you want to call the super class default constructor. But if you want to call super class parameterized constructor, then you need to write the value.